Hi, Ella. Let me unmute you. All right. So did you have any questions before other people get here?
I just had a quick question. So I couldn't find the
The
like
Frappy?
effort thing.
The Frappy?
Yeah, I could not find that, and then I think I got it from somebody else. Somebody like took a picture of it and sent it to me.
Okay,
They
yeah.
like the book because the book had like page 134 and then 136. It didn't have any page 135.
Yeah,
So
it's
like
actually listed under the chapter 2 exercises, the 2.2 exercises right at the end of that. I sent out an email this morning. Someone else asked me the same question.
like I even looked through like all of that stuff and I still couldn't find it. Even like the under the chapter 2 exercises, it just wasn't there.
Okay,
So I think
let me
I'm done.
switch my screen. Tell me if you can still see it here. Let's see here. Can you see my like Google right now?
No, I can't. Your screen is dark.
Okay, let me try and get that back here. Let's see, how do I share my screen? Let's see here. I got to get used to this Zoom still. There it is, share screen. All right, now can you see my screen?
Yep.
Okay, let me switch here and see if we can get you to the right spot for the future at least. All right, so I need to go to my online book. So after you sign in there where it was, and I know that was a little confusing. I didn't realize it worked that way, but under the two, excuse me, under the 2.2 exercises, are you seeing those?
Yes, I'm seeing it
So it's
now.
way down at the bottom of this after all the exercises. That's where the Frappy was.
Oh, okay.
Yeah, and
I
I wasn't very
I see
clear on.
where I thought it was under the chapter 2 review exercises. But okay, I found it now. We're good.
All right,
So I
good.
will get turned in as
And
soon
we'll
as
talk about
possible.
those as soon as some more people get on here. So that's going to be
Alrighty.
the first thing we're going to talk about. So,
And then I have one more quick question.
okay.
So for density, or not density, I don't know what it's called. For the normal distributions, when you say to like find this number, so like say like 20 is the mean and then like 12 and then 5 is the standard deviation and then you say to find like 23, you have to like explain that process because I
All
feel
right.
like I get there but
Right.
I don't think that
You see this normal curve on my screen right now?
yeah.
Okay. So what do you say the mean was?
So like the mean is 20
Okay.
and
And
then
let's say the standard deviation is 5.
yeah.
Okay. So notice this thing will automatically fill that in for you.
Yeah.
Okay. So if I wanted to know what percent scored greater than a 23, so just any normal curve always has that 68 within 1,
Yep.
95 within 2, and 99.7 within 3.
Hmm.
So if I was just guessing what percent was above 23, we know it's going to be more than what? What percent?
Know that it's going to be above 50 but
Good, but it's going to
below
be less than, how much is above 25? If there's 68
above
in here, 100 minus
and then
68 is 32. So this is half of 32 or
uh 16.
Right, so if I just went in there and I said above 25 and hit calculate, it's about 16%. So like you were saying, if I want to know above 23, I hit calculate and there's about 27% above there.
Alrighty. So is
This-
that your answer, or do you then have to find the z-score?
Okay, so it depends on what the question is. If they
Mhm.
wanted, they might ask you what the z-score is. And this z-score would be, what would you guess the z-score might be?
Like 1 point, like
Now
a
be
little bit
careful,
over.
what's the z-score for the mean?
Oh, sorry. A little bit above 0.5, so like
Yeah,
0.6.
perfect. Now you got it. Yep. So the z-score might be 0.6 or something like that. And you could get that by taking 23 minus 20 divided by 5. Okay. But if they just ask for what percent was above 23, you can just say it's 27% or 0.27.
Okay, so that's where I was getting confused. Like for some of them, like they said that like I was getting the area or probability and I was getting 25, but then they would give me the z-score. So I just have to read the question better.
Yeah, it's they get a little tricky, so you just got to read in there. I'm going to see if anyone else is here yet. I got to figure out which button to click on. All right, let's see here. Whoops, I got someone coming here, so here we go. Looks like Latoya's coming in. Hey, Latoya, are you there?
Yep, I'm here.
All right. Nathan?
Howdy.
All right. So we'll get going in just a second here. We'll give some people a couple seconds. Do you guys have any quick questions before we start?
No, I'm good.
Okay. Can you guys all see that normal curve on my screen?
Yeah.
Yeah.
All right, perfect. Now that I kind of found that calculator, that makes these problems a lot easier. And then you don't have to try and pull up that TI-83. That TI-83, the reason I usually use that in class is if you decide to take the AP Stats class after the second half of this class. So maybe next year you might want to take the AP statistics class and then take the AP test. On the AP test, they wouldn't let you use this tool, but they would let you use the TI-83 calculator. And they also let you use that on the ACT. So normally in class, we use the calculator a little more. But since we're doing everything online, this makes it all a lot easier. And if you understand this, jumping to the calculator goes pretty quick. So that's why I kind of switched over to this one. It should make these problems a lot easier. Did everyone find that when I sent out the email?
Yep.
Yeah, that might be something you want to put on your bookmarks bar because we'll probably use that quite a bit. Hey, Josh.
So
You awake this morning? Looks like you're still in bed. All right, he must have left us here. All right, Josh. I'm going to unmute you. All right, so we'll get going here in just a minute. We'll give people a second or two to see if anyone else shows up. You can hear me, right, Josh?
Yeah.
You can see that normal curve on the screen?
Yep.
All right, good. All right, so there's a little confusion on that Frappy problem. The Frappy, I know the online book, finding the page was a little tough, but under chapter 2.2, 2.2, if you go to the 2.2 exercises, it's way at the end of those. And we'll look through that in just a second. Let me get a drink of water. I'll be right back. All right, I'm going to get started here since it's 10:45. So first off, I'm going to pull up that Frappy. Let's see here. And I got that somewhere here. Go back. Okay, so it was on the chapter 2. Let me see if I got them down here. I got too many windows open. All right, so let me go to the ebook. So chapter 2.2, and I'm going down to the exercises here. And it was way at the end of those exercises is where that was, if you didn't find it. Okay. So on this first one, it said the distribution of scores on a recent test closely followed a normal distribution with a mean of 22 points and a standard deviation of 4 points. So whenever you're doing those, I think that tool that I sent out, the normal calculator, is probably the easiest way to do this. So the first one said, what proportion of the students scored at least 25 points? So when they say at least, it's 25 or more. So this calculator, everyone remember how to get to that? It's in my email, but I also put it on my homepage underneath all the weeks. So down below it says normal calculator. So in this problem, they told you the mean was 22. The standard deviation is 4. Now, as soon as I put that in, this fills in your numbers. And remember, whenever you have a normal distribution, which a lot of things in the real world are normal distributions, I'm going to mute everyone for just a second. And then, so hopefully you can all still hear me. Give me a nod if you can hear me, Ella. All right, good, thank you. I just did that because we're getting some feedback. I'll turn you guys back on in a second for questions. But remember, there's 68% of the data falls between one standard deviation either way. So you start at your mean in the middle and you add 4 over this way and subtract 4 over this way. 95% falls within 2 standard deviations, and 99.7 falls within 3 standard deviations. Now, we use this normal curve a lot because like a lot of things in the real world will fall into a normal distribution, like weights of babies when they're born, or heights of 16-year-old males, or heights of 16-year-old females. Most of the people are at the mean. 68% fall within 1 standard deviation, 95 within 2, etc. Okay, so on this test, the mean was 22, the standard deviation was 4, and then I could just say the question was how many scored at least 25. So I want to know how many scored above 25 if it says at least, and I hit recalculate down there. It shows you that there's about 22% of them did. Okay. Now, I'm going to unmute them, everyone. Okay, so if I wanted to know what percent scored more than a 22, what would that be, Latoya?
Would you put in 20?
Don't have to work too hard. 22 is right in the middle, right?
Oh, 50%.
What percent would be above it?
50.
50. That's all there is to it. Okay. What if I wanted to know what percent was above 26? A little bit tougher. What would that be, Nate? A little bit tougher.
That would be
How much is within one standard deviation?
4. Oh, I guess
What percent?
65.
Okay. These numbers you might want to write on your paper somewhere because those are ones that you want to memorize. But between one standard deviation is 68. Within 2 is 95. And within 3 is 99.7. So
Is that just for this one? Or does that work with multiple?
that works with every normal curve.
Okay.
Okay, that's the definition of a normal curve. They always will have those same probabilities in between. Okay, so how much was in here, did you say, Nate? Or did we say?
68%.
Okay, so how much would be on the outside then? What's 100 minus 68?
32.
Okay, so how much would be just on this side then?
16%.
There we go. So if I wanted to know more than 26, it'd be 16%. Everyone catching that?
Yep.
Okay. How much would be above 30, Josh?
So would that be 2 deviations?
Okay, that's 2 standard deviations. So between
So
14 and 30 is 95.
so would it be 5%?
That's on both ends. I just want this side.
Okay, so 2.5%.
There we go. Okay, so that's how that empirical rule works.
Yep.
And that's an approximation, but it's pretty close. Okay, if you use a calculator, it'll be a little different because it gives you more decimal places. But that's close enough for your answers too. So if I just asked you what percent was above 30, you'd tell me what, Josh?
2.5%.
And you'd have the answer. That'd be close enough. Okay, now if I use the calculator and I said above 30 and I hit calculate, it says 0.0228, which is pretty close to 0.025. Okay, so the empirical rule is close enough. This one gets you a little more precise. Okay, all right, so that was the first question in there. I'm going to go back over here. Move this around. Okay, it says, what's the 31st percentile of the distribution of test scores? Okay, now to do that one, we could use that formula, z equals x minus mu over the standard deviation. So in this case, the 31st percentile, okay? So let me see if I can. I don't want to take too much time trying to do this. It's hard to write on the screen. So I'm going to switch to a Word document here quick. Okay, so I want z equals, I'm going to see if I can make this look like it. I insert an equation. Okay, and then I want to put in a function. Okay, in the top, I want x minus the mean. And on the bottom is the standard deviation. Now in the book, whoops, I didn't get my n in there. See if I can make that a little bit bigger. Okay, in the book, that's supposed to be minus mean, not equals mean. Okay, that will give you how many standard deviations above or below the mean you are. Okay, in the book, they'll use symbols. And again, you got to kind of learn to speak the language in there. So in the book, it'll look something like z equals, let me insert another equation. This is a lot easier on a chalkboard, okay? So I'm going to do x over y, okay? So they'll say x, which is my score, minus, and then they're going to use a symbol for the mean and a symbol for the standard deviation, okay? So when you see that stuff in the book, hopefully you know what those symbols mean. So the X is my score, mu is the mean, that's the mean of the population. What else do they use for the mean sometimes? Have you noticed that?
X bar.
They'll use X bar. So they use mean when we're talking about the whole population. They'll use X bar when it's coming from just a portion of it or a sample. Okay. So same thing down here. Sigma's coming from the population. If they use an S sub X below it, that's coming from a sample. So a sample is a statistic and a parameters from the population. Okay, so they say, remember your P's and S's. Population's a parameter, okay, sample's a statistic. So on this one, we could plug those numbers in. We're trying to figure out the score. We know the mean is 22. We know the standard deviation's 4. Do we know what the z-score is? What score did they say in there? 31, I think, didn't they?
Yeah, 32.3.
Okay, so I'm gonna switch windows back here and get back to this thing. So a 31 is gonna be over here, right? What would be the z-score for a 31, Ella?
The z-score for 31 would be
Approximately?
2.2, 2.1.
Yeah. So now finding a z-score, you'd have to look in that table and find 0.31, we'd have to figure out what percent was over there and try and figure it out, which is kind of a pain. So we take our 31 minus the mean, which was 22, divided by 4. So if you have a calculator there, 31 minus 22 is 9, and then 9 divided by 4 is 2.25. So somewhere about 2.25 would be our z-score there. I'm going to show you an easier way to do this in just a second, but it's nice to know where they're coming up with this stuff. So if I went back to that problem to get my z-score, I'd take my 31 is my X minus my 22 and divide it all by 4. And that gives you the 2.25. Okay. So now they still want to know what that value is. Okay. So what score I'd have to get to be at a 2.25. Okay. So that gets a little bit more interesting. So let me see. I got to look back. Someone read that question to me again. I lost my train of thought already.
What is the 31st percentile of the distribution of test scores?
Okay, so yeah, I already screwed up. 31st percentile. I thought the score was a 31. 31st percentile. Anyone guess where that is when 31% would be less than? So how much is less than 22, Nate?
50%.
How much is less than 18, Josh?
16%.
Very good. So it's going to be somewhere in here is the 31st percentile. Okay. So if I want to do that, that's that other link I sent you, that z-score calculator. Okay. So in here, if I say my raw score, let me go down here a little bit here. So if I want to figure out a p-value, so I'm going to put 0.31 in there and hit this button. Okay. It would be a quick way to find the z-score of 0.49585. Okay. So I needed to know the z-score in order to do that calculator. Okay. So at the 31st percentile, it was a percentile, not a score. Sorry, I read that wrong. Okay. The z-score would be 0.49. So then when I went back over here, I would say what was my number again? Anyone remember? Was it 0.439?
49.
0.49. So a little less than half a standard deviation. We're trying to figure out what score we need to be at the 31st percentile. So then you could solve this thing for x. So if I want to get rid of the 4 on the bottom, what do I do to both sides?
Multiply by 4.
So if I take 0.49 times 4, that gives me 1.96. And over on the other side, I got rid of the 4, so I just got x minus 22. So this is just a basic algebra problem.
Add 20.
Add 22 there, and your answer would be 23.96. Okay. So on that one, you got to figure out what the z-score is, and that calculator, that other calculator I sent you, does that real quick. Then you don't have to look it up in the table in the back of the book and find out what the z values are. That calculator gets it right away. Okay. Now, if you were able to get to that PI83, it makes life even easier. Okay, so let me, I got too many bookmarks up here. Get to my calculator. Hopefully it works here today. It was messing up on me yesterday. Let me get logged in. Okay. Yeah, it looks like that calculator's acting up a little bit. So we might have to do it that way. Somehow it disabled my account on the calculator. So we'll just do it the other way. Okay. So that answer, I kind of bounced around there. So that answer for that problem would have been 23.96, would have been the score, which is at the 31st percentile. And what's nice about this graph then, let's see, where'd that go now? Somehow I lost that thing, darn it. I don't know where that went. Here's my normal calculator, and it can't be reached. All right. If you would have looked at that graph, I don't know, I must have too much stuff going on here, so I'm losing some of my stuff. Let me try and close a couple of these. Zoom's eating up all my memory, I think. Okay. All right. So somehow my tabs went away too. So let me go back here. I'm going to try and get back to that Frappy. This is the pain about working online.
You're telling us.
Yeah, I know. Okay. Get back to the ebook, chapter 2. Okay, and we were on 2.2 exercises. Okay, so to speed this up a little bit, is everyone okay on B there? Hopefully that made a little sense. I didn't bounce around too much. But C was a little bit tougher. Okay, C said the teacher wants to transform the test scores so they are approximately normal, but they have a mean of 80 and a standard deviation of 10 instead of the 22 and 4. Okay, so they want you to find the values of A and B I can put in there. Now remember, this kind of looks like y equals mx plus b. At some point in math, they switch this around. So this is a plus b times x. So the b is the slope, the a is the y-intercept when they write it this way. But it's just, they call that a linear conversion. And last chapter we said in a linear conversion that if I multiply, it affects everything. But if I add and subtract, it doesn't affect the spread of the distribution. Okay, so we're going to keep that in mind. Now, let me pull up. I'm just going to go to the answers here to make this speed up a little bit. So let me get into Google Classroom. I posted these answers for the Frappy here today. So you can look at those when we're done too. If that don't make sense, so I'm going to go here. Okay, so we went through that first one. There's the work for the second one. Okay. All right, let's see here. So there was a z-score of negative 0.5. Okay, we solve that for x, and we get somewhere around 20. Okay, and again, it just has to be close. You can round to 1 or 2 decimals. It's up to you. Okay. All right, now I'm on question C. So in this one, because if I add, it doesn't affect the measures of spread, the first thing I can figure out, I don't have to worry about the A in that equation. I'm going to get my new standard deviation equals B times my old standard deviation. Okay, because adding and subtracting doesn't affect the measures of spread. So I want to go from the old standard deviation, which was, let's see here. Does someone, here we go. Let me look at the problem here. Okay, mean of 22, standard deviation of 4, and I want to transform. Okay, so my old standard deviation was 4, and I want it to go to a 10. So then it's real easy to solve for B. Just take 10 divided by 4 and you get 2.5. Okay. So because the standard deviation isn't affected by adding, I just have to worry about the B times X. Once I got that, I know what B is. We said B is 2.5. Then I can get the new mean. So a new mean, okay, I want it to be an 80. I have to add something to 2.5 times the old mean. Okay, so 2.5 times 22. I multiply that, subtract it from 80, so I get A is 25. So my transformation ends up being, what in my new score will be 25 plus 2.5 times my old score. Okay. All right, hopefully that kind of makes sense. Always solve for your standard deviation first because it only has one variable because adding doesn't matter. So you can just plug what you want for a new one, what you want for an old one, then you figure out what B is. And then once you know what B is, you can solve for what A is. So it's just like a kind of an easy algebra 1 problem when you get them stuck in the right spot. And again, vocabulary is so tough in this, so that's why it's really crucial that you do that vocabulary before you start a chapter, so then you can read what the book actually says. And I know that's tough without me being able there to explain it every day, but doing that vocabulary becomes very important. And then let's look at the last one on that Frappy. So the last one says, before the test, the teacher gave a review assignment for homework. The maximum score was 10. The distribution of scores had a mean of 9.2 and a standard deviation of 2.1. Would it be appropriate to use a normal distribution? Okay, so if the mean is 9.2 and the standard deviation is 2.1, what's 9.2 plus 2.1 about? Anybody?
12.3.
Like,
About 11.3, right?
Or did you say 2? Oh, shit.
So the mean is 9.2 and a standard deviation is 2.1. So if I just go one standard deviation above that mean, I'm already at 11.3, right? But what's they say the maximum score is?
10.
It's 10. So if it's a normal curve, I should be able to go out 3 standard deviations each way. I can't even get 1 standard deviation above it till I hit the maximum score. So it's not going to be a normal curve. Okay, so just to kind of put that in context here. Ah, dang it. I don't know what's going on with my normal calculator, sorry. Is anybody else, is your normal calculator working right now?
Yeah.
Okay, so mine's going away, so I don't know what's going on with my connection here, but that's that one. So hopefully that helps out on the Frappy a little bit. And again, I have those answers posted there. Okay, so because we had a hard time getting to it, you can still turn those in if you want to get full credit. Okay, how about on the Anybody look at that chapter review? So under the chapter review, there's an AP practice test. Was there any problems on there that were causing you issues that you want to talk about? So I'm just going to ask a couple of them. Okay. So let's see here. Pete got his score. He got a 63 on the test. It said it put him at the 73rd percentile. Okay. Standardized test, he's at the 73rd percentile. What does that mean? What do you think, Latoya? What's percentile mean?
I'm sorry, I just lost connection. What happened?
So again, I'm looking at this 2.1. I'm just going through the practice test. Okay, so let's say you're taking that NWEA test and you get a score back and it says you're at the 73rd percentile. What's that mean? Does that mean you got a 73% on it? Whoops, sorry, let me unmute everyone. Somehow people got mute. Try and unmute everyone. There we go. Okay. All right. So what's that mean if I'm at the 73rd percentile, Latoya?
Depending on what the percentile is, it's how many times you go up from the center.
Okay. Hold on to that thought for a second. What did she just describe, Nate?
How many standard deviations she was above.
Right. So you just gave me a Z score, Latoya. Okay. A percentile means what, Josh?
It'd be like how much better, what percentage of people you were better than.
There it is. So if I'm at the 73rd percentile, that means 73% of the people scored less than me. So if you were at the 60th percentile, what would that mean, Latoya?
There's 60% beneath you.
Yeah, there'd be 60% less than you if you're at the 60th percentile. Okay, that's all percentile means. So in this one, it says Pete did better than 73% of the test takers. So again, if you got the vocabulary, and use your vocabulary sheet when you're taking the test, that's absolutely fine. It's open book, open notes. Okay. And if you're taking a test and you have questions, feel free to email me. I'll try and be online the whole morning that you take the test, or you can email me at any time. Okay. So I can answer questions even during the test. Okay. So if I looked at this number 2, okay, where do you think the mean is on that, Ella?
The mean is approximately at 2.
Yeah, so the mean's right in the middle at 2. What's the standard deviation on that, Josh?
2.
It's 2. It's what you're counting by. Okay. So in that one, standard deviation would be closest to 2. Again, once you understand the terminology, these problems are pretty easy. Okay. If I looked at 3, rainwater's collected and water collectors at 30 different sites near an industrial complex. The amount of acidity was measured. Mean and standard deviations are 4.6 and 1.0. When the pH meter was recalibrated back at the laboratory, it was found to be in error. It can be corrected by adding 0.1 units to all the values and then multiplying the rest by 1.2. So if you write on your paper, y equals a plus bx, okay, they tell me that I add what? Josh, what'd they say to add?
0.1, and then to multiply the result by 1.2.
Okay, so instead of the a, we got 0.1, so I got y equals 0.1 plus 1.2x. That's a way you could write out that linear conversion. So again, y equals 0.1 plus 1.2x. So in a linear conversion, multiplying affects everything. Adding and subtracting does not affect measures of spread. So the mean and the standard deviation, which one of those is a measure of spread, Nate? Whoops, you're muted. Let me unmute you. Okay. Which
Good.
mean and standard deviations a measure of spread, Nate?
Standard deviation.
Good. So when we're thinking about that, if you got that linear conversion 0.1 plus 1.2 times x, it's not going to get affected by the 0.1. So to get the new standard deviation, you just take the old standard deviation of 1.1 and you multiply it by 1.2. Okay. What else are measures of spread besides standard deviation? Ella?
The
Things that would tell you how spread out it is. What's the first one we did? Maximum minus minimum
maximum minus minimum would be the range.
would be the range. Okay. So if I told you that the range of this distribution was 10, what would be the new range? How would I get it? I just take that 10 times, anybody?
Is it times standard deviation?
Now, remember that, again, I'm sorry I don't have it on my screen, but I don't want to switch too much here. But on your paper, you should have y equals 0.1 plus 1.2x. That's what they told you in here. Multiply by 1.2 and add 0.1. So a range is a measure of spread, so it's not affected by adding or subtracting. So if the old range was 10, the new range would be 1.2 times 10. Okay. Now, all other measurements that aren't measures of spread are affected by adding and multiplying. And again, it's either adding or subtracting or multiplying or dividing. They just use that in general. Okay. So if the old mean was 4.6, how will I get the new mean, Ella? Why do people keep getting muted here?
You would take the mean times 1.2.
But I'd also have to do what, Nate?
Add 0.1.
Add the 0.1. Okay.
What is the 0.1 for?
So 0.1, let me see. Let me try and see if I can get something up here where I can show this to you. I want to get a screen where I can draw on. I got to look back to where that is. Give me just a second here to try and explain this linear transformations. So I got to search for a link here quick. I'll be done here by 11:30 at the latest, so we can get you guys out of here, but my computer's kind of slow here. All right, so let me search. I sent that to Aaron. I'm going to do something that I can try and draw on. If it'll show up. I don't know why my computer's so slow today. It's working really fast. I got pretty good internet here, but I think the Zoom's slowing me down. All right, here we go. So let me draw on the screen if I can get my link to work here. All right, so it's AWW. All right, so this is coming up here. All right, so different situation. I'm going to kind of draw a normal curve here. And let's say these are our class heights. So let's say our class height has an average of, say, 68 with a standard deviation of 2. And it's kind of hard to draw on the screen, but you guys get the idea. And let's say the tallest person in the class was 75 inches. Okay. So 74 would be 3 standard deviations. So there are more than 3 standard deviations out there. And then I'm going to draw a couple lines here. Let's say the shortest person was 60 inches. Okay. What's the range of those values?
15.
Okay, the range of the values is 15. Now, here's what you think of on those linear conversions, okay? All right, I'm gonna try and, I want everyone to fit in here. So if I did a linear conversions, think of it, I'm gonna make you all wear 2-inch shoes, okay? Shortest person is now what, Josh?
62.
62. Tallest person is now what, Ella?
Or 77, sorry.
77, right? Okay, so really all I did was slide that whole distribution to the right. So my range is still what?
15.
It's still 15. That's what we're saying, that adding and subtracting does not affect measures of spread. So I'm not sure, but my standard deviation, I guess I answer is 2. If I slid it all over, my standard deviation would still be 2. Okay. Now, if I convert all your heights into centimeters, how do you go from inches to centimeters? Do you know that, Nate?
Times by 2.54.
Good. So if I multiplied these all by 2.54, that's going to change those numbers. The shape is still going to stay the same, but the numbers are going to change. So then the standard deviation, instead of being 2, it's going to be 2 times 2.54. Okay. Now, if I had you wear 2-inch shoes and convert it to centimeters, then to get my new mean, I'd have to multiply it by 2.54 and add the 2 to it. Okay, but the standard deviation would just still be 2 times 2.54. Okay, adding or subtracting does not affect measures of spread, but it does affect all the other numbers. And measures of spread are like the range, the standard deviation, and the other one we talked about was the IQR, the distance between quartile 1 and quartile 3. Okay, those are measures of spread. They don't get affected by adding or subtracting, but they do get affected by multiplying and dividing. Okay. All right. So let's see, where were we? So on that one, so to get the new mean then, what would I have to do, Ella?
To get the new mean, you would have to multiply everything by 1.2 and add 0.1.
Perfect. Okay. So if I told you that the median was 3, the new median would be 3 times 1.2 plus 0.1. If I told you the IQR was 5, what would the new IQR be, Latoya? The IQR is a measure of spread. It's only affected by multiplying.
So then 1.2.
Times 5, right? Whatever the old one was. Okay. So that's that linear transformation stuff. Okay. That's a little tricky, but once you get used to it, it's not too bad. Just remember that adding does not affect measures of spread. Multiplying affects everything. Okay. Everyone okay on cumulative relative frequency? Okay, so this says about what percent of these adults consume between 4 and 8 ounces per week. So remember, if it's a cumulative relative frequency, 4 ounces or less would be about 20%. Okay, 2 ounces or less would be about 10%. So this says between 4 and 8. So if I go 4, I go up to here, I look over, it's about 20 ounces. 8, I go up to here and it's about 60 ounces. So it's the difference between those two. It would be about 40% of them. Okay. So when you're doing this, you know, if you want to draw the sketch or just put a little ruler on your online book, go straight up there and straight over. So at, what was the first one? 4 ounces would be about 20. 8 ounces would be about 60. Between those would be about 40%. Okay. All right, so on the next one, the average yearly snowfall in Chillyville is normally distributed with a mean of 55. If the snowfall in Chillyville exceeds 60 inches in 15% of the years, what's the standard deviation? Okay. Now, I'm going to try this normal calculator one more time. If not, I'm going to bail on it. All right, it's not working for me. Sorry about that. So let's see here. Get back to that one. All right, so we were on Chillyville. Okay, so if you on your paper, here, I can do it on that other thing. I'm going to clear this off if I can. Erase, so clear everything. Okay, if I get my pen back, if I draw this thing in, it's a normal distribution. Sorry, I got to switch back and forth to get to the problem. I'm going to get it in my book here so I don't have to switch back and forth. All right, so in Chillyville, it has a mean of 55, and they want to know what the standard deviation is, okay? So the mean is 55. We don't know what the standard deviation is, but it exceeds 60 inches in 15% of the years. So if I went out here, one standard deviation, how much is above that? Josh?
One above the standard deviation,
How much would be above one standard deviation?
so it's 15%.
Now be careful. There's 68 in the middle, right? 60
Yeah.
within one. That leaves 32 on the outside. So out here would be
30 or 16%.
16%. Very good. Okay. Now they say it exceeds 60 inches in 15% of the year. So that's a little more than one standard deviation is 60 inches. Okay. So we know the standard deviation is less than 5, but it's pretty close to 5. Okay. So in order to do this problem, it says it exceeds it in 15% of the years. How much would be less than that? If 15% above, that leaves 85% below, right? Okay, hopefully everyone got that. But I'm going to go back to that other link that we had. It's that, all right, where did it go? All right, I got 2 other bookmarks up here. So this makes these a little easier. Let me just get to our website. So that, come on, switch for me. All right, so down below here, I added a new link. It's this Z-score calculator. Okay, and I'm gonna go down below. So remember that a p-value is how much is less than it. So it said it exceeds it in 15%. So I have to put a 0.85 in here. And then it's going to give me that my Z-score would be 1.03. That's a lot easier than looking it up in the table. So I'm going to round it to 1.04 since that's a 6. I'm going to go back over here to my whiteboard. So that's about 1.04. Okay. So I know my Z is 1.04. Sorry, it's hard to draw with a mouse here. Equals, okay, and the question, I gotta remember what the question was. It says, what's the standard deviation? So we know the X is 60. We know the mean is 55. This is really bad writing, sorry. And I'm gonna divide by the standard deviation. So we're back to an Algebra 1 problem. We'll check your Algebra 1 skills. How would I solve that thing, Nate?
Multiply by your standard deviation.
Good.
Or, yeah.
Perfect. Yep. So I'm going to have 1.04 times the standard deviation. Again, just think of that as one variable. Equals, on the other side, if I take 60 minus 55, it's 5. Okay, that's supposed to be an S of X. So then to finally get the answer there, what would I do, Latoya? If I got 1.04 times something equals 5, how do I figure out what that thing is?
You can divide 5 by 1.04.
You got, and that will get you your standard deviation. Whatever 5 divided by 1.04 is, okay? So those are a little tougher because first you got to look up what the z-score is in that formula, which was z equals x minus the mean divided by the standard deviation.
What does the z variable signify or stand for?
Okay, good question. What's the z-score mean, Josh? If I have a z-score of 2, when, let's say I say you have a z-score of 2 in class heights, what would that mean? You're pretty tall. Your z-score might be 2. What's that mean?
That I'm in the top. It has to do with I'm gonna be in the top 2 percentile.
Okay, nope. Percentile is different than z-score. What's a z-score of 2 mean, Ella?
It means it's 2 standard deviations away from the mean.
Good. You're 2 standard deviations above the mean. So this 1.04 meant that I'm 1.04 standard deviations above the mean.
What does P stand for?
A P is a percent that's under there. So if I asked like what was the P for 55, and 55 is the mean, the P would be 50% would be smaller than it.
Got it.
So the P is the percent. I know it's bad to read that stuff, but okay. So P is always a percent. Okay, a z-score is how many standard deviations above or below the mean. So if they tell you that 16% scored above you, you know that 84% scored below you, and then you'd have to go to this thing, put in your 84, and it'll tell you what your z-score is. Okay. You could always look up 0.8500 in that table in the back of the book and then try and see where it lines up. But this is much easier to do that. Okay. All right. Any other questions jump out at you?
No.
Let's just look at, I'm going to look at one more here. So in this one, if something's skewed, what gets pulled towards the skewness? Josh?
Is it the mean? Like, what do you mean? Like, when you say
So,
it's pulled towards the sheet?
They're asking you for where the mean and median is on this thing.
Yeah,
So think of this as grades. You got a bunch of grades around 100, right?
yeah. The mean.
But you got 130.
The
Is that,
mean's
what's
gonna
that
be
going to
more
affect, the mean or the median?
It's gonna affect the mean.
Yeah, it's going to kill your average, right?
Yeah,
It's only going to make the median move one spot.
yeah.
Okay, so in this distribution here, most of your data is over here. I would guess that the mean is probably C and the median's D. Okay, you could maybe go with the mean is D and the median is E. So let's see what it says here. The mean is E. Okay, the mean isn't going to be E because it gets pulled over when I get that low grade.
Mm-hmm.
Okay, the median is C. The median only moves one spot, so that's too far over. Okay, third quartile is D. Third quartile is 3/4 of the data, and that looks like more than, I don't know if that's 3/4 of the data over here because there's a lot of data over here. Okay, the area between A and G, which is the whole area of the curve, right? That is equal to 1. Okay, so the only one that worked on that one was E. Okay, because the whole area under any distribution is always equal to 1. Okay, so to not keep you too long, is there any last ones you'd like me to look at?
Are these going to be the types of questions that we see on the test on Monday?
They won't be the exact ones, but they'll be, if you understand all these, the test should be pretty easy.
Okay.
Okay, this is just, we always have a review like this, which is the same type of questions. And if you understand these questions, then the test should be real simple. Okay, if I don't have any questions jumping out, feel free as you look through this today to send me which one that you'd like me to explain, and I can record a little video and explain that. Don't be afraid to ask me questions. Okay, I get lonely here when no one asks me any questions. Okay, so if you have questions, feel free to ask me those, and then I'll record a little video. Or if it's easier to talk through it, just say, hey, could you Zoom me? And we'll set up a time where we can talk through those questions. Because I know some of the terminology is hard. The math behind statistics isn't hard. It's just speaking the language. Okay.
I just have difficulties understanding where things go when it's like talking about it, but otherwise I understand everything else.
Yeah, that's just what I'm trying to say. It's just when they start throwing those symbols in there, the mu and the X bar and the sigma and all those other things, it's just learning what those different symbols mean, and like you say, where to plug it in. Okay, the math behind it isn't hard. You just got to learn to speak the language, and that's what's tougher about the online learning. We can't have those conversations in class. So when those come up, feel free to email me. Okay, I'll send a video if that doesn't help, or if you'd rather talk through it, we can do a Zoom session. Some of you have done that already, and I think it clears stuff up pretty quick. Okay, so again, I don't want to make you all sit through Zoom sessions. I know I'm putting Josh to sleep there. Okay, but hopefully this helps a little bit. Okay,
No, it
so
helps a lot.
feel free to ask questions whenever you want. Okay, that's what I'm here for. Okay, I won't bother you all the time, but if you need help, go ahead and reach out to it. And even during the test next week, so Monday we'll have a test over chapter 2. And then if you have questions, even during the test, I'll be on our normal class time. I'm actually on from 8 to 4. So I'll try and respond stuff real quickly if you're taking the test. If you're doing it later at night, I'm usually around my computer, but you might not get an immediate response. Okay, because I do have a life outside of this. Okay, so I'm working on some stuff on our new house stuff, but 8 to 4, I'm always around during the week. Okay, and you can send me emails on the weekend too. That's fine. You can send me it at night. Okay, but I may not respond exactly right away during the night. Okay, but I'll try and get back to you as quick as I can.
Are we gonna have a final in this class?
We will, and it'll just be something similar to one of these. The only difference, the final will cover everything that we've done, and
Yeah.
everything will build up. It won't be real long. It'll be like 10, 15 questions. It'll be
Yeah.
open book, open notes, and we'll review before we do it.
And or when do you think we'll be done? Like what day for like I'm just wondering because every teacher's kind of been different with their end date for this class for the seniors. So I didn't know if you had a different one.
Well, the last I heard, is the 15th the last day?
Well, for me, I'm done the 6th.
You're done the 6th. Okay.
Yeah,
So we will, let me double check on that and I'll get back to you.
okay.
We'll figure that out.
Good. All right. I just didn't know if there's
Yeah,
anything I need to get done.
I hadn't heard exactly when the seniors' last day was, so I'll double check on that and let you know for sure.
Yep. Sounds good.
All right. So if everyone's good, I'm going to close this off. Okay. But feel free to email or text or email or whatever makes it easiest to help you on these problems. Hopefully everyone has a good day.
Yeah.
See you later.
Yeah.